Our next speaker on the program is Dr. Rick Grant. Rick is going to talk to us about some fiber digestibility things, but Rick is originally from New York. He got his BS from Cornell, his PhD from Purdue, and was on the faculty at the University of Nebraska for several years before he joined as Minor Institute as the president of the Minor Institute back in 2003. He does a lot of research related to animal behavior, time budgets, as we've probably all heard. Also silages, forage, and particle size, which is what he's going to be talking about this morning. So Rick, welcome.
All right, well, thank you, Judd. It's a pleasure to be part of this year's Penn State virtual conference. As Judd indicated, my topic for this morning is focusing on concepts of fiber degradability and particle size of corn silage, but also incorporating that within the big picture of feed bunk management. In my first slide today, really, this is my outline. So I'm going to focus initially on forage fiber, NDF degradability, or UNDF 240, the inverse of that, particle size, and how that affects intake and other responses. But I really want to come back around to how the feeding environment interacts with these characteristics, and particularly how that response kind of gets mediated through changes in rumen pH. So that'll be my focus for today. Let's get the ball rolling. We only have about a half hour or so this morning or today. Let's talk about how we can integrate rumen fiber degradability and particle size. We've known forever, of course, it seems like that NDF is a very good predictor, measure of the feed's ability to stimulate chewing activity, and it's related to intake. That goes back to Merton's NDF intake system many, many years ago. We've also known for many, many years that if you can split NDF into two fractions, undegradable and potentially degradable, well, you can get a lot more information out of that forage analysis, right, in terms of predicting cow response. And so we can talk about the degradable fraction for sure, and time series fermentation endpoints give us rates and benchmarks to use. But with my few comments this morning, I'm going to focus more on the undegradable fraction. And certainly at this point, over the last 4 or 5 years, it's not a new concept anymore. UNDF 240, the in vitro measure at long-term fermentation of indigestible NDF. And its usefulness really comes back to its relation with gut fill, dry matter intake. And it's also useful as a benchmark because it's responsive to the environment, maturity, and genetics. And that's really not my focus for today, but those are all good attributes of UNDF 240 as a measure, as a benchmark. Really where I'm going with this in the first part of this talk is there value in integrating this measure of undegradable NDF with some measure of particle size? And I'm simply starting with physically effective NDF, or the PEF fraction of that specifically, and seeing if we call this, you can call it what you will, but we've called it physically effective UNDF 240. Is there value in that in some of these high corn silage and even hay crop silage based diets? Well, long story short, I think there is, but let's just show you some of that data. First of all, let me just say that the PEF, I think everybody in this audience would be familiar with that, but it can either be measured sort of with the standard dry sieving approach that Merton's defined when he defined the PE-NDF system as greater than the 1.18 millimeter screen, ROTAP, or some similar dry sieving vertical system, or probably more commonly for a lot of the people in the audience using the Penn State particle separator system. And there's some work out there which would say that if you use the 4 millimeter screen and higher, so these 3 sieves right here, added together, those give you a PEF, which is pretty much the same as the standard method, at least for corn silages and a lot of our common hay crop silages, and the TMR based on those. All right, so we put together a data set over the last few years of high producing cows, and it's important to keep that in mind. And in these 5 different studies, forage percent ranged from maybe a low of 40, 42% over here, up to probably about 65%. But for today's purposes, the key thing is that all of the forages, the forage base in these 5 studies, were primarily, if not exclusively, corn silage. You can see we had conventional, BMR, even had one study with unified, so we had a flowery endosperm in play as well. The point is these were higher corn silage diets. And we wanted to look at what did we see in terms of relationships with these diets in terms of UNDF 240 and intake, and then as I'll show you in the next slide, the physically effective UNDF 240 and intake. So in this first slide, we have The UNDF 240, and in this database, it varies from just under 6 up to 11%, which is a pretty good range. Of course, on the lower end, we'd be worried maybe about subacute rumen acidosis and particle size in that respect, maybe a little larger particle size. At the upper end, with some of these treatments, we're definitely looking at, say, above 10% anyway, constraints on intake, and can we reduce particle size to try to promote greater intake than you'd predict from just straight up UNDF 240. Well, as you can see, with this range across this data set, there's a useful relationship with intake. About a third of the variance in intake is explained by UNDF. If we combine particle size and UNDF into this metric I just introduced, and again, the range is maybe from about 4 up to 7.5%, we do get a tighter relationship. Now about 60% of the variance or variation in dry matter intake is explained by this combination where we've integrated particle size, or PEF, and UNDF 240. Now, what about energy corrected milk? Here again, we have UNDF 240, energy corrected milk, and you can see about 60% of the variation now. So it's useful. It's not perfect by any means, and we think about all the factors that affect milk production. It's no surprise, but certainly it's a useful relationship just with UNDF 240. And then if we take the next step that we've been doing over the last couple of years and try to incorporate PEF as well, that relationship becomes even tighter. All right, so I'll just back up one. There's a relationship with UNDF 240, and then the same data from the same studies, but now we've multiplied PEF times UNDF 240, and it's much, much tighter. So we've been wondering if this relationship is kind of interesting, if it's real. Is it just a fluke of 5, well-controlled studies? And that's certainly something we need to consider. I will leave you with this as food for thought today, though. A field study done by the Rock River Group a couple years ago and reported at ADSA meetings looked at high corn silage diets, and they looked at just UNDF 240. So they had 55 commercial dairy farms, and they looked at just the corn silage in the ration. They took samples on these farms using NIR, okay, not wet chem, but NIR, and they measured NDF and NDF degradability, UNDF specifically, at 240. So the TMR was about 57%, plus or minus 5% forage. Corn silage was about 37% of the dry matter, plus or minus 8. And as you look at their results here, for every unit increase in UNDF 240 in the corn silage only in these TMR, you can see they saw about a 0.3 and about a 0.6 kilo per day increase, decrease in intake and energy corrected milk. All right, so about a little over a pound and a half decrease in energy corrected milk. Now, I didn't dwell on the slopes I just shared with you in the previous 4 slides, but if you look at those, and remember, our data is on a dietary basis, and Geiser's work just looked at the corn silage component. Nonetheless, they are certainly reinforcing of each other, aren't they? With our TMR-based UNDFs and PE UNDFs, we saw about a 0.38 kilogram per day decrease in intake and a little over a kilo decrease in energy corrected milk. So I think there's something there. I don't want to over-interpret this, but I see value in this going forward with these kind of diets. And particularly for today, we're talking about corn silage-based diets. And as I said, the vast majority of our database is based on these sort of diets. Of course, we haven't focused on alfalfa-based diets, pasture systems, and so forth, but hopefully we'll get to that. But for today, there seems to be real value in this. All right, so there's that. Now let me shift gears just a little bit with that introduction and focusing on particle size and UNDF 240, just to simplify things. How does the feeding environment influence the cow's response to these 2 forage factors, these 2 forage characteristics? I'm going to just focus on pH. It's not the only thing, but certainly if cow's a ruminant, it's got to be a major thing for sure. I can't imagine a cow that has any level of digestive efficiency or well-being without having good rumen pH, a desirable rumen pH. And don't have time to get into it, but there's a lot of data out there more recently and some older data which shows that in ensuring rumen health, and again with the focus on ruminal pH and its relationship with rumen fiber fermentation, that will boost and give you in most cases the most efficient milk component synthesis, milk fat, milk protein. So let me just throw out these 2 points. I'm going to summarize some of Matt Campbell's work when he was at the Institute several years ago, working on his PhD. how will these cows respond to the ration, to the corn silage in the ration, or any forage for that matter? In this panel here, overcrowding, right? I'm not going to say where that farm is, it's not important, but certainly we see too much overcrowding in the dairy industry today. And Mac's work would say that on the same diet, you would get up to 2 hours per day on average greater subacute rumen acidosis. We measured that as pH less than 5.8, okay, with overcrowding. And that was about twice the effect we saw when Mac manipulated PE-NDF. All right, that really surprised me as a nutritionist. Now on the right side, of course, we have an empty bunk, right? Not pushed up, not enough feed delivered. And interestingly, in Mac's work here, he saw up to 9 hours per day on average greater subacute rumen acidosis when you combined overcrowding with feed restriction, right? And so what I'm getting at here relative to today's topic is, what does that do to the cow's ability to ferment the fiber that you're feeding her, corn silage or anything? And I've been joking, well, kind of joking with people that I speak with, the perfect recipe for a low rumen pH, which is guaranteed to reduce the cow's response to the forage fiber, is first of all to feed a fermentable diet. All right, and you can look at some of the metrics there, but finely chop it. Make sure you're on the low end of that UNDF 240 scale, and of course, feed a little bit of rumen fermentable starch. It doesn't take much really to begin to see some milk fat depression. So you have that fermentable diet, which almost everybody feeds in some form. Then you overcrowd the bunk in the stalls and you feed to an empty bunk. And that's almost a surefire way to have Sarah in your herd. All right, and overcrowding the animals, of course, can induce slug feeding, but we've learned with Mac's work, maybe even more importantly, or just as importantly, it impairs rumination while the cow is in the stall. And this recumbent rumination, or rumination while lying down, I don't have time to get into it today, but is critical relative to the cow's ability to stay out of acidosis. And just real quickly, if you look at this figure here on the right, on the x-axis, this is fraction of rumination time that occurs in the stall. And as you see, you get up to 80 or 90% or 100% of the rumination time occurring while the cow is lying down, recumbent. The y-axis is hours per day less than 5.8. You can see that all things being equal, the cows that can get the majority of the rumination done lying down have healthier rumens relative to pH. All right. I don't have time to get into that right now. Maybe there'd be a question, but this is important relative to how the cows respond to forage NDF. All right. And here's a consideration that for the people in the audience who feed cows for a living, how many times have all of us looked at a forage test? It's right there in front of you, and you think that based on this NDF digestibility data, the cows should be doing better. They should be doing better, but they're not. And I think there's a lot of reasons for that, of course, but I think one thing we've been overlooking is that lab analysis measures the potential NDF degradability in this case, right? But poor feeding management, as I've just said, can really impair that potential. It'll reduce it. And think about the pH. That degradability was measured in vitro at pH 6.8 or thereabouts, or it was, based on an NIR based on that sort of in vitro system. But what is the pH in the cow's rumen that you're feeding? And if you're seeing this disconnect between the digestibility on the forage analysis and what's happening in the pen of cows, this could be part of it. So think back to the last few slides I just shared with you, right? Subacute rumen acidosis can range from 2 to 10 hours a day or more for individual cows, right? Under these conditions of overcrowding, feeding to an empty bunk. And there's lots of data out there, right? I quoted myself, that's kind of easy to do, I suppose. But there's a lot of data out there which shows that when you have that low a pH, you're really going to reduce NDF fractional digestion rate by up to 50% when it's less than 5.8 for those hours. So that could be something that we've overlooked for too long relative to what we see in terms of our cows responding to corn silage or any NDF for that matter. And hopefully that makes sense to the audience. All right, so there's that. So think about rumen pH and think about, of course, how that's going to influence fiber digestion, but also think about how the cow's environment is going to affect that pH. All right, let me take it one step further here and talk about the whole animal. All right, we're talking about fiber degradability and particle size, but now let's focus on the cow's behavior, particularly chewing behavior, but also resting, so we can talk about time budgeting and that balance between rumination in the stall, which I just said is so critical, and time at the bunk eating. And the key concept here, of course, is not a hard one, but we're focusing on the rumen, aren't we? We always focus on the rumen and what happens there in terms of fiber degradation. But we have to remember that, of course, that rumen is inside of a cow. And the environment that cow is in can have an enormous impact, right, on what happens in the rumen in terms of fiber fermentation. So in talking about, rethinking particle size, and a couple of years ago, Luis Ferretto and I did a review where we looked at all of the forage research we could find where people have changed forage content, NDF or NDF degradability, and what did it do to eating time and rumination time? Well, what we found is that you can alter eating time by plus or minus an hour a day. Multiple studies have shown that by changing these fiber characteristics, right? And in fact, the topic for the day, just looking at brown midrib versus conventional, when people have done one-to-one replacements, that change in digestibility, degradability of the NDF can give you plus or minus 30 minutes a day eating time, right? The cows can process the more digestible BMR faster at the bunk. They can eat it faster. And oftentimes rumination is affected less. It's not unaffected, but it's affected less in some of these studies. So what's going on? And at this point, probably people in the audience have heard some of the story. This particular slide has gotten a lot of work, really, but it's great data. This is an Italian group, and they've looked at the effect of across different types of forages, different types of grass, hays, ryegrass, grass silage, corn silage, TMR, varying widely in particle size. Okay, how does the size of the particle size in the bunk compare to the swallowed bolus? And I have to admit, I mean, this isn't the first data; it's just more recent. When I read this, I thought, well, gosh, I've been missing something. I think a lot of us have. Is that with some of these diets we're talking about today, right, that are corn silage based, hay crop silage based, typical Northeast, upper Midwest diets, the cow takes the time to chew to a relatively uniform bolus size. And I'm not saying that's with every type of forage. Pasture, for instance, is much, much different, right? But what's happening with these type of diets, it seems like, is that they're spending more time chewing when you have longer particle length, and then she's swallowing a similar, let's say, 8 to 10 or 11 millimeter bolus, all right? And I would say we have similar data. I don't have time to get into it today, where we fed a high corn silage diet and changed particle size with chopped hay. I think Randy Shaver has some similar data, right? So it's not a new concept. It's not a unique concept to this paper, but it's an important one. So I think it might be an overlooked component of forage quality, this time spent eating at the bunk. Because if she's spending more time at the bunk chewing to a uniform size before swallowing, and the data would say that might be 8 to 10 millimeters across several studies, all right? She's forced, she being the cow, she's forced with a trade-off, isn't she? Between eating time and then recumbent rumination, all right? I'm gonna share with you just a couple of slides which I think will reinforce that. So what happens if you don't adjust for particle size, NDF or NDF degradability, when we're feeding these type of diets? Well, I like this study here. This is some work that was reported a few years ago where corn silage was the primary, not the only, but the primary silage forage in the diet. Also had alfalfa and some alternative forages. It was done in China, so I had a few forages we wouldn't commonly feed here. But I think it's safe to say that the majority of the cow response was due to corn silage, if you look at the formulations. And what they did in this study is they fed from 40 to 70% of the ration dry matter as this forage blend, heavy corn silage, alfalfa. And they didn't change particle size, they didn't change the digestibility or the source of the silages as they went from 40 to 70, they just fed more of it. So it's not what you do in the real world, but it's instructive to see what happens to these cows when that happens, all right? So if you look at dry matter intake, first of all, of course, it dropped as they fed 40 up to 70%, and it makes sense. They were just overwhelming the system with fiber, okay? Look at eating time, trying to time some concepts I've just been sharing with you, all right? It really dropped by about 107 minutes a day or so. And particularly if you look at when it dropped, it happened when they got up to about, what, 60 to 70% of the ration dry matter, all right? I need to drop down to one of the footnotes down here and just remind you that all of the behavior work that's been published, for the cow to have normal, desirable, I'd say even healthy eating patterns, not slug feeding in other words, that eating time has to occur within 3 to 5 hours a day, all right? And that's been known for a long time. And if you look at eating time here, when did these cows have to go beyond that? as they moved up to 60 and up to 70%, right? They were pushing 6 or more than 6 hours a day eating time just to process this feed in the bunk and get it swallowed, all right? Now, rumination time is also impacted. It increased, though not nearly to the extent that eating time had to increase to accommodate this difference in forage. Now, if we look at total chewing time, right? That's just adding eating and ruminating together, of course. You can see that, isn't it interesting that that balances out with the cow's resting time? I always joke, I love this slide. It's got to be a bit of a fluke of the study, of course. It doesn't always, balance to the minute. I can't imagine that, but it does make the point, doesn't it? That as you increase forage content, if you're not thinking about what you're asking that cow to do at the bunk in terms of chewing time, to process that feed to a relatively uniform size before she swallows it, you're going to increase eating time, and that cow has to create that time somewhere. And we know from time budgeting information, it's usually at the expense of resting time. And what did I just say about the importance of rest relative to rumination and ruminal pH? You see, we have to think about the whole system, don't we, if we expect to maximize energy capture from NDF. All right, so let me pull this together in my remaining minutes. So with all of this in mind, where do we sit relative to particle size recommendations if we're trying to optimize cow response and cow behavior? Well, here's a slide. Actually, we've had various versions of this since Kurt Kotanch was here at the Institute. We revised it just slightly in the last year, but not dramatically. And to orient you, so this is based on the Penn State particle separator. Here's the top, the two middle sieves, the 8 and 4 millimeter in the pan, all right? And here's the Penn State, as far as I know, the most recent recommendation. I guess Judd can correct me if I'm wrong here. And then here's what we've been recommending. They're very similar. We've just tweaked them based on some of this information I just shared with you relative to the importance, I think, to the cow of getting her work done within 3 to 5 hours at the bunk, and then lying down, hopefully 12 to 14 hours a day. So if you look at the top, right? I didn't talk about sorting, but clearly that's the most sortable material. So much information is out there on that. I don't like it to see that being 0% for sure. That makes me nervous. But 2 to 5, 6, 7, even up to 8% is okay as long as it's properly processed and isn't sorted. But when you see TMRs with 10 to 15%, I think that is really too much for these kind of diets. I really focus more and more, and I know a lot of nutritionists do, on this 8 millimeter screen. And it kind of makes sense given what I just shared with you, relative to what the cow swallows with these kind of diets, right? It's still functional. It still stimulates rumination. In fact, the 4 millimeter screen is the PEF sieve, PEF's benchmark, if you will. So focus on this 8 millimeter pan. And we like to see 50% or more there if you can, because those TMR tend to be the ones which allow the cow to eat within 3 to 5 hours a day, and then she can still ruminate 7 or 8 or 9 hours a day, right? It seems like things work very efficiently with these corn silage-based diets when we're in this range. And to get there, it has to be part of a system. I always forget to bring that up. This doesn't work too well, I don't think, if you're grossly overcrowded and the cow can't get to the bunk when she wants to. So it's part of a system. You need to put that in there. And then I borrowed this slide with Bill Woodley's, he gave me permission to do it. I didn't steal it, I borrowed it. But when I saw him present this a year or so ago, and I thought, this is a great way conceptually to think about how you adjust chop length, TLC, theoretical length of chop, for forages if you're trying to hit these targets, all right? And he's got his, his guide up here is, in millimeters, and I've given you the little cheat sheet here, inches and millimeters. But the point is, he's got it here for haylage, grass, alfalfa. But if I focus on the brown arrows, silage for today, what Bill is saying, and I think it makes sense when you have drier corn silage, chop finer. As it gets wetter, chop coarser, you want to juice up for one thing. And this is driven by the cow's needs, but also, frankly, it's driven by, maybe even more so, by getting it to pack well in the silo. And I guess that's something I haven't dwelt on, but it's something we should, is that, with a lot of these silages, whether it's corn silage or other types of silages, grasses, alfalfas, get it to pack well in the bunk. And don't be so concerned about having such coarse particle length. I'm not sure the cow really needs it in the bunk, all right? And it certainly doesn't help in terms of packing. So keep this idea in mind. And just maybe this is more of the next slide is maybe more of a typical way to see particle sizes. But I think if you can get these sort of distributions for corn silage and other types of forages, right, you're going to have a pretty good chance of hitting some of the TMR targets I just shared with you, and some lengths of chop that we've seen nutritionists use, farmers use. It gets them in the ballpark. Okay, I think that's the important point. So wrapping up for this morning then. Okay, if we're trying to optimize energy for corn silage, particle size, NDF degradability, or I focused on undegradability, but they're inverses, and forage percent. We need to make sure that the cow can consume that feed in 3 to 5 hours a day. I didn't share all that behavior data with you, but take it on, just hopefully believe it, that is when the cow will have the best eating rates for a healthy rumen. Populate the rumen as much as you can with the second screen of the Penn State particle separator. Those are the ones that the cow is going to chew her TMR2 anyway, by and large, before she swallows it. So you avoid excessive eating time. And I'm not saying minimize time at the bunk. I'm saying try to do it so that the cow can spend no more than 5 hours a day there. And then she's going to have all that time that she needs for recumbent rumination, which is so critical to keeping rumen pH where we want it. And again, we didn't know that till Mac did his work, but to me it was pretty eye-opening. And not a topic for today, but the other part of this whole system then is to keep feed available, right? I mentioned feed restriction can, when in combination with overcrowding, can reduce rumen pH. It can be 9, 10, 12 hours a day. The cow is subclinically acidotic when she's faced with an empty bunk and overcrowding with a fermentable diet. So don't put her in that situation. And then finally, as a take home, to optimize energy capture from forage, corn silage, and other NDF, it's feed bunk management and its forage fiber characteristics. And I think we've done a disservice maybe by not focusing on both of these over the years. And with corn silage specifically, it's NDF and it's NDFD or UNDF 240. And I didn't talk about starch and starch D. I know there's other folks talking about that, but there's going to be an interaction and we can't separate those. And particle size is so critical. Okay. And then the last thing I'd say, duty bound, feel like I have to say this, always prioritize the cow's behavioral time budget. Eating, resting, ruminating. I feel like a broken record, but they're biologically linked. The cow will sacrifice eating time to rest. And as I just said, in her ideal world, 90% or more of her rumination needs to occur while she's lying down for a rumen pH in the desirable range. So with that, I think I'm done. And if there's any questions, I'd be happy to entertain them. Thank you.
Thank you very much, Rick.
Yeah.
Questions? I guess I'll start off, Rick, with one that data where you're looking at longer forage going in front of the cow. She's chewing more. What does that do to salivation rate though, and how does that intertwine with maybe modifying rumen pH?
Well, I think it must have an effect, right? I mean, we focus on rumination as the only source of salivation sometimes, right? But I guess I didn't say it. I was maybe talking too quickly, but chewing during eating, cow salivating, and if she's working harder to chew, she's also is creating saliva, no doubt, right? But you can't discount the value of that buffering. I guess my point, Judd, would be that within the cow's ideal 24 hours, it'd be good. She ought to be able to take advantage of that 3 to 5 hours of eating and salivation during that 3 to 5 hours while she's eating. But in terms of salivation, more salivation being elicited by having to chew more, right, to reduce particle size and swallow, if I'm following your question, I think I'd rather see her lying down and chewing and ruminating. And I think part of Mac Campbell's responsiveness in terms of pH and where the rumination occurred, where the chewing occurred, was when the cow's lying down and she's resting. I mean, she's kind of reinforcing what we know to be the situations that tend to maximize salivation rate. You see what I'm saying? So I guess yeah. I'm not discounting chewing during eating, but I'd like to put that in its place and then really get the cow lying down and ruminating. And I think that helps explain Mac's pH data.
Okay, thank you.
Yeah. All right.
Hey, Rick, I have a couple questions. Can you hear me okay?
Yeah, perfect.
So the first question I have is on the UNDF 240s. Some people will use UNDF 30s or maybe some other time point.
hmm
Is UNDF 240 a better predictor of intake versus UNDF 30? Or do you think, it doesn't matter which one you use, just find one and stick with it?
Well, certainly the latter is a good way to go. And I'm not laughing because that's a great question, and everybody has that question. And I need to say, I jumped right to UNDF 240 for a couple of reasons, because it's in our database. Clearly, it's related to intake, and I didn't have time today to talk about other time points. I know that 30 hours has been also usefully related to intake, and perhaps maybe more so to meal patterns. Does that make sense? And I wish I'd had time to go into some of this, but when we looked at some of the relationships in that database I shared with you, the best single measure we had for dry matter intake, kilos or pounds per day, is UNDF 240. I think of it as a ballast. It sets the limit. But in terms of number of meals and meal length, things of that nature, it was the fast pool, which is driven a lot by 12, 24, 30-hour time points. Hopefully that helps answer your question. So they're both important if we really want to talk about meal patterns and dry matter intake. But I feel comfortable with UNDF 240 as an intake predictor. I'm not saying UNDF 30 isn't important. I know Larry Jones and others have seen good relationships with corn silage specifically and UNDF 30. Yeah.
Well, and with what you said earlier there about how critical it is for them to have 3 to 5 hours of max eating time, and then along with that the problems with overcrowding, then those lower time points are essentially just as important. And so looking at both together, it seems to make sense.
Yeah, and honestly, as we go forward, I should put this caveat. I hope anybody who's listening to this will listen to all the questions, because but this whole idea of combining PEF and UNDF 240, I'm not saying it's the only thing to do. It worked. I was surprised. I mean, we tried that first because we had UNDF 240 measured on anything. Everyone has PEF. It's like, oh my gosh, this works. But that's not to say you can't get other measures of degradability, right? It could be a rate. It could be an earlier time point, combination of points together with some particle size measure might give you a much better predictor. Okay, so I'm not saying what I present is exclusive by any means, but it should start us thinking down a certain road is what I'm hopeful of.
Yeah.
Does that make sense?
Yeah, it does. Yeah.
Yeah.
So next question, you when you were talking about the things that can contribute to SARA, I think your chart said rumen fermentable starch greater than or equal to 19%. How are you defining rumen fermentable starch? Are you defining it on a time point, or is there? If you can elaborate on that a little bit, that'd be great.
Sure. And I struggled. I deleted and added that number 3 or 4 times before I gave this talk, because it's not. I know I wouldn't get into it today. But it's based on some work that one of my students just finished up here. And so that's a very simple measure. It's just based on starch content times a 7-hour starch degradability. All right. From Cumberland Valley, actually, if that helps. So very simple measurement. And then what she found, though, is all of her UNDF 240s in her treatments, they were based on corn silage, either conventional or brown midrib, to try to vary UNDF 240 in the diet. But she was right around 6 to 7.5% UNDF, really on the low side. And what she found with these diets is that when she got up to just 19% or so, I think it was 19.2% rumen fermentable starch measured the way I just described, she saw some pretty significant milk fat depression, right? Changes in A to P ratios you'd expect. And so we're like, wow, when people are pushing the slower end of the UNDF 240 spectrum, you're getting great intakes, but you need to really think about how little starch it takes to push the rumen sort of over that edge, right? In terms of milk fat depression. Yeah. So that's where that 19 came from.
Okay.
Thanks for asking that question.
That's interesting. Then the last question I think I had was going back to that chart from, is it Woodley or Woolley?
Yeah, Bill Woodley.
Woodley,
Yes.
yeah.
I should say he's from Ontario. He's a private consultant.
Okay,
there.
yeah. So that's a great chart.
Mhm.
Pretty simple to read and easy to understand. But my question is, if you know this answer, especially when it comes to corn silage, at what point is corn silage wet versus corn silage being dry?
Oh man, that's a
Talk
good
about the
question.
farmer. That's what they want to know. Just
Yeah.
tell me when my silage is now too dry that I ought to start thinking about chopping it finer.
Well, you could say like 35.2, right? I mean, I don't. There's obviously there's a range, of course, but as you move out of the mid 30 range and head toward 40%, at least most of the silos and the silages we work with, those are where we begin to see some benefit, right? The
Yeah.
drier it is, and wet, of course, you're more worried about juicing up, I think, and just silage.
Right.
As you get closer to 30 or high 20s, that's clearly too wet to worry about trying to fine chop.
Yeah.
I don't know. I don't know that I want to quantitate it more than that. Maybe Judd could jump in, or maybe you have some thoughts. But as you go from 35 on up, is where I start thinking of it as quote drop.
From what I see of farmers in general, they don't think that the stuff is getting dry enough to chop finer unless they're or above 40% dry matter.
Well,
And,
for sure there.
I
think in the high 30%. I don't know, Judd, you can chime in for sure. But as you get into the high 30s, we do it all the time on our farm, and we have really good components and really good intakes, and we chop finer than most people would feel comfortable with, and especially when we get above 35, 36 and move into that 38, 39% range.
Yeah, I think if we can get that message out to them that even those moisture ranges deserve a look, or dry matter ranges deserve a look. And it's so easy nowadays, at least with the newest processors and choppers, to do it on the fly. It makes sense to do it.
Mm-hmm.
Yeah. But thank you.
Yeah.
Yeah, I appreciate that comment. Actually, Tom and we did a workshop or a meeting last year, and that was part of the topic, because sometimes people like to chop it a lot longer than they should when it gets a little dry. So I think your 35 is good.
Yeah.